All right, let's get back into it. As I said right at the end of the previous video, we were going to take a deeper dive into something kind of new, yet not really new, just a change in vocabulary. Instead of calling holes and vertical asymptotes holes and vertical asymptotes, we're going to be calling them removable and non-removable discontinuities. Remember that a discontinuity is a point at which the graph breaks. A hole is a discontinuity because the graph breaks at a hole. A vertical asymptote is a discontinuity because the graph breaks at a discontinuity. And then there's one other type that we'll talk about in just a second. A removable discontinuity is a hole. A hole is a removable discontinuity. All right, another way to think about a removable discontinuity is that if you can simply relocate a point, so for instance, if I take this point and relocate it right here, and that fills in the break, that's a removable discontinuity. So you can visually represent a removable discontinuity based on the idea that you can remove that discontinuity by filling in one or a finite set of points. Even this one, where the point doesn't exist anywhere, I could still fill in that hole just by making up one extra point, and I've removed the discontinuity. So both of these have a hole at x equals 3, but we no longer say hole, we say removable discontinuity at x equals 3. So if I asked you to describe the discontinuities in this graph, you could simply say that there's a removable discontinuity at x equals 3. A non-removable discontinuity is a discontinuity that cannot be filled in just by fixing a point or two. It would take an infinite set of corrections in order to fill in, or in order to fully connect the graph. Now, the one on the left I hadn't talked about yet in this lesson. This one's called a jump. At x equals 2, we have a jump in the graph. We talked about piecewise functions way back in Unit 1. I think it would have been lesson 1.4 if you want to go back and look at it. But piecewise functions often have different rules that it follows based on different intervals of the domain. So the graph looks like this for x is less than or equal to 2, and the graph looks like this for x is greater than 2. Notice that it's closed here and open here, so it never actually fails the vertical line test. This is still a function. A graph that just abruptly changes position, that's just called a jump. And here, of course, we have a vertical asymptote, which is a common type of discontinuity. Both of these are referred to, and that vertical asymptote itself would be at x equals 2. But both of these could be referred to as non-removable discontinuities. The one on the left is a jump, the one on the right is a vertical asymptote, but altogether, they are non-removable discontinuities because they cannot be fixed just by filling in 1, 2, or a finite number of points. You'd have to fix an infinite set of points before they actually fully connect. Those are graphical representations. Let's just take another quick look at the algebraic, which again, we've already done. The removable discontinuity is the one where you can remove the factor. So x equals 4 was the discontinuity. It would cancel, so it's a hole or a removable discontinuity at x equals 4. Down here for the non-removable, remember x minus 4 canceled, so x plus 3 did not. Over here, so x equals negative 3 will be the non-removable discontinuity, or the vertical asymptote. Recall, here's what a piecewise function looked like. So you can kind of imagine the function is 2 when x is less than 0. So if you actually don't have to imagine, let me go ahead and do a quick little sketch. Here's my axes. Here's x equals 0. Here's 1, 2. So when x is less than 0, the graph is the horizontal line y equals 2, and that's going to be open. And then for x greater than or equal to 0, it's going to be y equals negative 2, and it's going to be closed. So that would be the shape of the graph on this one. So notice we have a jump, which is a non-removable discontinuity. So jump at x equals 0. This one has a vertical asymptote at x equals negative 3. Either one, though, can be rephrased as a non-removable discontinuity. You're still welcome to use the old vocabulary of hole, vertical asymptote, and jump, but you also want to be familiar with removable versus non-removable in case you're asked to describe it as such. Speaking of which, take a moment right now, pause the video, hit play when you're ready. I want you to identify and describe the discontinuities. And when I say describe, I want removable and non-removable. Pause here, play when you're ready. So just like we did in lesson 2.4, where I wanted you to identify holes, vertical asymptotes, and all that stuff, we're going to start by factoring everything out. Factor the top, factor the bottom. Discontinuities are anywhere that the bottom equals 0. So finding discontinuities is just like finding domain restrictions. It's literally the same thing, just calling it something different. So my domain restrictions or my discontinuities are at x equals -2 and x equals 3. The factor that cancels is removable, so x equals -2 is a removable discontinuity, and the factor that does not cancel is non-removable. Final answer. Remember, x minus 2 is neither removable nor non-removable because it is not a discontinuity, it's on the top. Here's another one. Pause here, play when you're ready. Factoring the top, I get this. Factoring the bottom, it just stays as x minus 1. I only have one factor on the bottom, so I only have one discontinuity. Discontinuity at x equals 1. Because it cancels, it is a removable discontinuity. All right, and let's do one more. This time, I'm just going to give you a picture. Same question as before, identify and describe the discontinuities. Pause here, play when you're ready. So anywhere there's a break in the graph, we have a discontinuity. So hopefully you recognize that there's a break in the graph at x equals -2, at x equals 1, and at x equals 2. So we have 3 discontinuities. Describing those discontinuities just comes down to, is it removable or non-removable? At x equals -2, it's a hole. A hole is a removable discontinuity. X equals 1 is a jump. So that is a non-removable discontinuity. X equals 2 is a vertical asymptote, so that is also non-removable. All right, take some time now to complete the practice before you do the quick assessment.